Okay, let's look at number 1. What are the 4 ways for a function to fail to be differentiable at a particular point? And they give you the coordinates for the point. Okay, so basically there are 4 main things that we had learned about. The first thing that we had learned about was a corner. The second thing we learned was a cusp. The third thing we learned was a vertical tangent. And the last thing we learned was a discontinuity. Okay, I'm just going to talk to you about this really quickly, even though it doesn't ask me to elaborate. Basically, a corner is when the slope, f prime at a specific point, as we approach that point, as x approaches a from the right, does not equal the limit as x approaches a from the left. So basically this means the slope from the right is a number, the slope from the left is a number, but these two numbers are not the same. Okay, a cusp. A cusp is when the slope as we approach a number equals plus or minus infinity from one side, and as we approach the number from the other side, using the slope, it approaches the opposite, minus or plus infinity. So basically a cusp was like, as you're approaching a value from one side, it gets infinitely steep in one direction. In this case, it would be negative infinity. As you're approaching from the other side, it gets infinitely steep in the opposite direction. Okay, whereas the corner would just be a number, and those numbers are not the same. Vertical tangent is when the limit as we approach the number from both sides, so I'm not specifying right or left here, of the slope is equal to infinity or negative infinity. Which means basically here I'm approaching a number, I'm going to go infinitely steep, and from the other side it is also infinitely steep. Discontinuity is basically any time a function is not continuous, it is not differentiable. All right, so then they give us a graph. They ask us to use the graph to determine the values of x at which this function is not differentiable. So the first thing I'm going to check is, where is this function not continuous? It's not continuous right here when x equals 0. It's not continuous, well, actually everywhere else it's continuous. So basically it's not continuous at x equals 0, so therefore it's not differentiable. So it's not differentiable due to a discontinuity in the actual graph. All right, let's look what else is happening. As we approach a from the left, the slope is a constant. As we approach a from the right, we also have constant values. This will have a positive slope. This will have a negative slope. So therefore, they are different numbers. So at x equals a, there is a corner. All right, we already covered this point when x equals 0. From the left, the function is approaching b, the slopes are approaching 0. From the right, the function is approaching 0 and the slopes are approaching a negative number. But there's a discontinuity, so it doesn't actually really matter. All right, at D, the slopes are approaching 0 from both sides, so therefore it's differentiable there. At E, the slopes are approaching probably something rather negative, maybe like -5 from both sides, so it's differentiable there. And it's differentiable at F, so we've checked everywhere on the graph.